Tensile stress occurs when a component is pulled apart, stretched beyond its elastic limit until microscopic voids link together and form a crack. Think of a game of tug-of-war. You pull and pull until the rope finally gives out and snaps in half. Under tensile loading, 4 primary crack types may develop. Ductile cracks, rough and fibrous with necking, often showing cupping or a shear lip. These are commonly caused by overloading, fatigue, material defects, or elevated temperatures. Longitudinal cracks, running parallel to the shaft axis, typically driven by internal pressure, material defects, stress concentrations, corrosion, cyclic loading, or thermal stress. Transverse cracks, perpendicular to the shaft axis and extending across the diameter, usually associated with overloading, impact or shock, corrosion, material defects, or fatigue. Brittle cracks, rare and characterized by a clean, sharp break with little deformation, often resulting from material brittleness, low temperature loading, high stress concentrations, or improper material selection. Ductile failures often display the classic cup and cone shape, whereas brittle fractures may show sharp, flat surfaces with distinct crack fronts pointing back to the origin. In manufacturing environments, tensile cracks are most frequently found in conveyor shafts, press frames, weld joints, fastener heads, and heat-affected zones, particularly in high-load assemblies such as gearboxes, tensioners, and lifting mechanisms. Prevention begins with proper material selection and stress relief heat treatment, as well as eliminating sharp notches and poor weld profiles. Managing overload conditions through alignment, lubrication, and torque control is critical. Detecting stress risers early and monitoring fatigue cycles can turn a small stretch into a warning sign instead of a catastrophic break.